So yes, welcome back. So dealing with finding the equation of a straight line. The first situation we have dealt with that. This is the second situation. The second situation has to do with when we are given 2 points. Then with the 2 points, you can actually find the gradient, and after finding the gradient, you can find the equation of the straight line. So what it means basically is that finding the equation of a straight line, you will need the gradient, right? You need a gradient and at least a point. The first one, we were given the point, and then we were given the point, we were given the gradient. Now in this second situation, this is where you don't have the gradient. So if you don't have the gradient, the gradient is an essential element or part of the equation of a line. So in the second situation where we don't have the gradient, you have to look for the gradient ourselves. Then from there, you can choose any of the points that you have been given initially and then combine it with the gradient that we found later to find the equation of the line. So this is the essence of this exercise, the previous one that we did. Now, if you care to know the other example that we didn't have time to look at the solution, or yes, this is the solution. So it's y is equal to 3x plus 1, or y minus 3x minus 1 is equal to 0. Now at the back there, in the example 1, however you substitute them, it doesn't change anything. The answer does not change, provided the substitution with the subscript of the variables were done correctly. That is the basic thing. So let's see here. If I have time, I'll come back to this. Better still, I'll use the example here for instance, and then that with this understanding, this first situation will be taken care of. Now let's come back here. So we are saying that to find the equation of a line given 2 points, A, that's x1 and then y1, and then point B, x2 and x2 and y2 on the line. So here's that we don't have the equation, we don't have the gradient, so we have to look for the gradient ourselves. Now let's see what is happening. Now we are assuming that let P be the point of the coordinate of P, that is the first point, sorry, x1 and y1 be any point on the straight line shown in figure this. Right, now the 2 points given are A, x1, y1, and then B, x2 and y2. So this is the graph. We have the point A, we have point B, and P is just in between them. So any point on the graph is actually a point which will have coordinates. So in this example, we have given that a P is of x and y. So that is it. And A is x1 and y1, B is x2, y2. Now, since A and B and P lie on the same straight line, they are collinear. Therefore, the gradient of AB is the same as the gradient of AP. I told you initially that the gradient along a straight line is the same. The gradient along a straight line at any point on a straight line is the same throughout. So any point on it has the same gradient. That's what it means. So now that we have the gradient of AB, right? AB to be y2, y1, and then x2 and x1. You know, the gradient of a line typically this is the formula. So that's what they are saying, the AB is of this formula. So gradient of AB here and here is what we are looking at, the change in them. That's what it means. We are looking at the change in them, right? So the change in them. So that's what it means. That's what we are using here. Cancel to what? The y2 and then y1, then x2 and x1. So we are dealing with B and P, B and A, sorry. So that is it. So this is one gradient. Now looking at also gradient AP is what? We have A. So marking here down to this point will be what? Y minus y1, right? X and y. So y minus y1 and then x minus x1, right? So we are dealing with AP, sorry, it's rather AP. It's rather AP, not BP, right? So AP will be here to here, right? So here to here. That is it. So hence the y minus y1, then x minus x1. You see. So we have it's more of like senior simultaneous equation, right? So we find the gradient of AB and then we find the gradient of AP. These are the two gradients. Now, even though we have said that they are the same, but in expressing them in variables, we have different variables. It doesn't matter. If you should put figures or values there, at the end of them they will be what? The same. What we are doing is we are deriving the formula for each of the gradients in each case. That's why you have different variables. That is it. Now, as pre-established that the gradient along a straight line is the same. If the same means that we have to equate the two. That's what it means. So gradient of AB is equal to gradient of AP. So that's the meaning. Therefore, equating equation 1 and 2, we will have what? This. Right. I hope you are getting the picture. Take it slow because I'm rushing through because of the time, but the understanding is the same. You can pause the video, do a simulation, and then you continue. So, hence, if the gradient along a point, a gradient along a line is the same along all the points, then if you have found AB and then AP, then they are the same. That's what we have established here. So we equate the two. After equating to the two, now we do normal mathematics, right? So mathematics, what it means is that we are now moving away, veering into the equation of the what? The straight line. Now we have seen previously that when we got something of this sort, we made the y's value to be the subject of what? The equation. The subject of the equation. No, don't worry. Let me not go ahead of ourselves. Get ahead of ourselves. Let me just do the math. Then I will explain to you why it is so. So equating the two gradients, we have this. Now here we are saying that multiply both sides by x minus x1. What it means is that we are doing cross multiplication, right? Cross multiplication. After the cross multiplication, we just made y into bracket y minus y1 the subject. So this is what it means. This is what we have here. That's why I have this. It's not any magic. We do cross multiplication and we made y minus y1 the subject. Hence this, right? So after making this, what do? We come down to make this. So y minus y1, m is equal to m x minus y, equation 3. So where m? So now that we have m, we have this. Now we know that m is of this. So y2, minus y1, yes, y2 minus y1 all over x2 minus x1, right, is the gradient of the line. Therefore, to find the equation of the line passing through the points, first find the gradient, what, m. So m once again is y2 minus y1 all over x2 minus x1 of the line using these 2 points. With these gradients and any of the given points form the equation. So for example, using a x1 y1, the equation of the line is this. So when we got it looks too much of words literally meaning, but what it means is that after finding the m, we do substitution, right, into the equation. So it's more of simultaneous equation. So what I can do now, you may find it difficult understanding the derivation or derivative, right? So at the end of the day, just understand that the equation of a straight line is the same as the equation of yes, it's the same. So we have 2 elements, right? So it depends on the situation that. So what I mean is, I don't want to get confused even myself. So what it means is that when you are asked to find the equation of a line, you will look at what you have been given, what the elements that you have been given, then you use that one to solve it. So the first thing to establish is that for finding the equation of a line, you have to have the m and a point, at least a point in the gradient. So if you have 2 points, it means automatically you don't have the gradient. So if you don't have the gradient, you have the 2 points, then you can find the gradient. After finding the gradient, then you can use any of the points to find what? The equation of the line. But a situation whereby you have been given the gradient itself and a point already, then that is enough. You can just zoom in using the formula. So that is what it means. I've still run out of time and I will see you next. Bye for now.